All right, we're back. We're on page 204. We are converting from rectangular to polar or polar to rectangular. We know a bunch of formulas. X is our cosine, y is our sine, r squared equals x squared plus y squared. Those are the most commonly used. And also tan of theta is y over x. Sometimes you use it. All right. The next thing we're going to do is it turns out another type of common polar curve. They're like a little less common in rectangular I don't know, because in rectangular you could have a center anywhere. This circle this page has just no margins and it's very frustrating. So this circle is like this. So it's centered at 0, 5, and it has a radius of 5. So it goes up to 10. Okay, I just wanted to draw that because it's going to be important potentially. So let's try to convert this. So what do we want to do? So I have a strategy. My strategy is first I'm going to expand, then I'm going to substitute. So I'm not going to do a polar thing first. I'm just going to go x squared plus y squared minus 10y plus 25 equals 25. Okay, so you'll notice the 25 and the 25, they're going to cancel out. So I'm going to do some substitutions. So the first one, this is going to be r squared. So minus 10. And then this, our y, is r sine theta. And then our 25s have canceled. So this equals 0. Okay, where do we go from here? Well, I can factor. So that'll be r minus 10 sine of theta equals 0. Okay, so now I can solve. So either r is equal to 0, which seems suspicious because I've seen the graph and I know that I am not always sitting at the origin, which means that what I just got was actually an extraneous solution. R equals 0 is just an extraneous solution. It makes sense in the context of the algebra of the problem. It doesn't make any sense in terms of the actual problem. So makes sense algebraically, doesn't make sense in context, it's out. Like that is not going to be our answer. So I guess our answer is going to be r equals 10 sine of theta. All right, so extraneous solution, that's gone. You got those in like algebra 2 sometimes when you're solving like radical things, you would get an extraneous solution. They show up. Trig equations, when you're solving those, you get extraneous solutions. They show up from time to time. So here, we're going to say r equals 10 sine of theta. All right, let's go back to the graph for a second and just look at it and see if there's any commonalities. So here's the graph. And I see, so the polar equation that we got was r equals 10 sine theta. All right, what am I noticing? I'm noticing this is centered on the y-axis, and we have said several times that y tends to go with sine things. And here's a case where we're on the positive y-axis, we've ended up with a positive sine. That's definitely a pattern. That's going to happen. And then look at that number 10 in relation to the graph. It's the diameter of the circle. This is also a pattern that will play out over time. We'll like do it eventually, but just start thinking about it. So we are tangent to the origin. So tangent to the origin. And then you're centered on the y-axis. It looks like you just get r equals the diameter times sine of theta. But if you're on the negative y-axis, what happens? We need to like work that out. So, and we will. Let's take a look at this one. So maybe the pattern's going to hold. So here, if we graph this, -3, -6, and then circle. So like that. All right. So it's on the negative x-axis. X tends to go with cosine, and the diameter is 6. So maybe I could just use the directed diameter and say that the diameter is -6. It's a direction. Maybe I think I might end up with -6 because of the directed diameter, and then cosine because it's an x thing. So this is my guess as to what I'm going to get. Let's actually do the work. So first I'm going to expand. Plus 9. Ooh, no. Oh my gosh. Do you see that? Algebra 1 jail. I think my Algebra 1 teacher used to talk about that. Like, oh, you made that mistake. You're going to Algebra 1 jail. Let's rearrange. X squared plus y squared plus 6x equals 0. You do enough of these and you're going to skip the step that I just did. You're going to like search out your x squared and your y squared. It's same as like trig identities. Like you would just look at it and be like, oh, here's a cosine squared, here's a sine squared. That's 1, and you go with it. Here, x squared plus y squared is going to be r squared, and you just kind of go with it. But for now, we're showing some steps. So that's going to be r squared, and then plus 6. This x is just going to become r cosine. And then the whole thing equals 0. So we get up here, go. Uh-oh, what's going on? Seem to have, let's see if I can recapture the, I crashed my notes. Let's see if I can bring them back. I sure hope so. I hope it didn't like ignore everything. No, it's right here. What the heck? All right. Yeah, and it's working. Woo! Disaster averted. Factor r plus 6 cosine. I don't know if I was like making a point before that happened. If so, it's totally this thing's fault. All right, so we get r equals 0, which we know is extraneous. We get r equals -6 cosine, which is actually what we guessed. And that's a good deal. So anytime you can find a pattern or think you find a pattern and then find another example, probably a good thing. So we get here -6 cosine of theta. So what's common about these? And this is really important because it doesn't work for every circle. They're both of the problems that we did. They're tangent to the origin. They're centered on one of the axes, right? So one of the coordinate axes. If it's centered on the x-axis, you're going to get a cosine thing. If it's on the y-axis, you'll get a sine thing. And that's like a huge generalization. And you want to know that because you see how much work we did. What I'm going to do the next time I need to do one of these problems, I'm just going to graph it. And then once I've graphed it, I'm just going to like say what the answer is. So that's my plan. All right, let's see. 3 secant of theta. So now I'm going from polar to rectangular. So I want to replace, what do I want to do? Let's see. So maybe I want to think about this. So I have r equals 3 over cosine of theta. One of the things, so it's more of an art form than some other things you do in math. Converting is like a little less obvious, right? So I could have replaced r with, so x is r cosine. So I could have replaced r with x over cosine, I guess, and like tried to do that. Would that have worked? Yeah, that would have worked, but like that's just not what you do. So here, r cosine is 3, and then I know that r cosine is just x. So this becomes x. What is that? It's like so many little dots, and I can't even do anything with them. Go away. There we go. X equals 3. So we already kind of knew that though, and this is where like building patterns comes in. So I look at that and I say like it's a cosine type thing, so it's probably going to be x equals something, and it was x equals 3. Just like look at enough of them, play with your calculator, see if you can get these to work. I don't know if I showed you how to use your calculator yet. If you go to Turk's Vids, there's a bunch of videos, I think, about using your calculator for sure. That's the YouTube channel, the channel you're actually currently on. If you search it for graphing polar on your calculator, it'll show you how. We're going to do it eventually, but maybe we didn't do it yet. All right, let's see. What do we do here? I'm going to cross multiply like right off the bat. So it's r sine theta minus 5 r cosine theta. Also, I'm expecting this to be a linear function because I know that, oh my God. Okay, because we've done a lot of these, right? And so like, I'm just guessing that this is gonna end up being that kind of thing. And if I look at it, r sine is y minus 5, r cosine is x, and then it equals 7. So I'm going to rearrange that and say 7 plus 5x or 5x plus 7, but either way, it's done. 5x plus 7. All right, and so what I'm gonna actually stop this video here, come back. I'm gonna do this 2 different ways. One way really fast, one way not as fast. And you're gonna wanna know both ways, but you're gonna wanna use the fast way. So I will see you in the next video when we discuss this.